Take it away, Giulia.
Hello, everyone. Welcome to the talk, Can eBPF Save Us from the Data Deluge? I think first thing that I need to clarify is what I mean by data deluge, and I believe it's pretty simple, and I'm just talking about big data, which is a trend that is all over the industry, all over cloud computing, and it actually only becomes a problem, and as in data deluge, the moment we actually put it in context in modern data centers. So let's jump straight in and look at what actually is happening in data centers. So usually we have compute nodes and storage nodes, and data is transferred to and from these two node types over the network. The problem is that now, on top of that, we have modern storage, which wouldn't be that much of a problem given that it improves the performance and the transfer and the throughput by a lot. Only it's maybe doing it a bit too much. So if we look at the throughput, we have that usually storage nodes can be comprised up to 64 SSDs. And this produces an aggregate throughput of 128 gigabytes per second, whereas the network with 16-lane PCIe interfaces usually accommodates 16 gigabytes per second of transfer. So we have a throughput gap, and the data that the storage nodes produce is higher than what the network can accommodate. And this is what we call data movement wall. So it's something that we should try to solve, and what I actually tried to solve with my research group and with my research in particular, focusing on storage. And I tried to solve it with eBPF, which is why I'm here at this talk. So what I did is applying some principles of eBPF usage for storage this time. And in order to understand how, I think we need to take a step back and look at eBPF and denial of service. eBPF is used in this scenario, and specifically let's focus on the compute node. Denial of service is when the nodes get overloaded from the network with too much traffic to handle. So they would stall if only eBPF couldn't be placed, for example, very early on close to the network interface card to prevent the packets from reaching even the compute nodes and stalling everything. Well, in a very roundabout way, what is happening on the storage nodes is pretty much the same. So it's a denial of service only in reverse, where the network is being overloaded by just too much data being produced from the storage node, which has a very high throughput. And the question that I tried to answer was, is there a way to actually put a stop here, just like eBPF was doing it on the other way around for denial of service attacks? Well, the answer is, it depends. So denial of service attacks, first of all, are malicious, whereas data transfers from storage node to compute nodes are not. They are business critical for the companies that are doing the transfer, so we cannot blindly drop the packets in the way we drop the packets in denial of service. So we need to do something different, but is there a way for eBPF to help us reduce the data transfer? Well, there probably is, because I, for example, implemented a prototype in eBPF filter reduce interface that is placed instead of on the network interface card, which is what eBPF is placed on to prevent denial of service attacks. I placed it as close as possible to the storage to intercept the data transfer and allow users to implement their own operations, like, for example, only select the data that is greater than 5 and compute the max, or only select the data that is equal to 5 and count. So we reduce the size, because at the end, we only have a numerical result, and the input could potentially be gigabytes of data. This is a prototype. It's available on GitHub, and I think it is promising, but it's not there yet as a thing that is ready for production, because eBPF right now for storage does not really have the same powers that it has in the networking stack as far as it goes for packet modification, inspection, and dropping. So I had to modify the kernel for that, and it's not ideal, of course, and I could only go that far with the current interface and support of the infrastructure. But I do believe that this is a promising direction. And in fact, during my research, I found that a lot of the industry and blog posts and development that is going on in eBPF is actually in the direction of allowing users to push a bit more programmability into the kernel using eBPF, which is such a solid interface for doing that. So I would be interested in the Q&A right now to actually hear what your opinions are on this, and if data transfer and storage could potentially be the next step for eBPF in this in the current data center infrastructure.
Amazing talk, Giulia. I was super excited about this. I hope we can connect you to all the relevant people in the Slack channel so we can get that conversation going.